Let us look at exercise 24, aka the exercise of do you know what it means to be a Lebesgue set. So basically this theorem kind of just follows from definition. So I have here, this is what the Lebesgue set is. It's the set of points where this thing is equal to 0. And this is only really, we only really consider the Lebesgue set for functions f which are contained in L1 locus, and so that's why we're restricting that there. So let epsilon be greater than 0. By continuity, there exists an r greater than 0 such that for all y in BR not x, we have f of y minus f of x is less than epsilon. That's just the definition of continuity. So then for all r between 0 and this fixed r naught, we have what? We have 1 over the measure of ball centered at x of radius r, the integral over this ball of fy minus fx dy, this whole thing in absolute value is equal to, well, the measure of this ball that's positive, and we're integrating a positive function with respect to a positive measure, so this is going to be positive. And so I'm going to write less than over here, 1 over mbr x. Then we just use our estimate above here, and we get epsilon dy. And so this is, if we bring this epsilon out, then we get epsilon times this thing is just, if we were to remove that epsilon, we just integrate the ball of radius r, and we get the measure of the ball of radius r. And so this is equal to this times measure of brx over measure of brx, but that's clearly just 1, so that's just equal to epsilon. This holds for all epsilon greater than 0. Oh wait, no. This holds for all r in 0 or not, so the limit as r decreases to 0 of this thing, and by dot I just mean all this stuff, but I don't really want to write that all again, so I'm just going to put dot there. That's less than epsilon. Now, this holds for all epsilon greater than 0, so that means that this limit must be equal to 0. But then, if the limit of the absolute values of these things are 0, then the limit of the things on the inside is 0. I'm going to write it out this time because this is basically going to be what we want. dy equals 0, i.e. x is in LF as desired. And there we go. We're done. All we really need to know is the definition of this thing, and we're good.